So guys, in yesterday class, we discussed about the routers. Okay. And I hope everyone is aware about it, how routers actually work. Fine. Now our next topic is switch. Okay. Before start switch, first of all, tell me, who can tell me one thing? What is the main uses of switch? What is the main uses of switch? For example, if I am talking about this is switch. So guys, main uses of switch is to connect the end devices, right? Everyone. What are the main uses of switch? The main uses of switch is to connect the end devices. Fine. For example, if you have a PC, how can you connect the PC? With the switch. And on switch, there will be a port, and that port is called which port? Switch port. What is called, guys? That is called switch port. Fine. And here we insert which cable? LAN cable. Which cable, guys? LAN cable. Or you can say Ethernet cable. Fine. So the main perspective of switch is to connect the multiple end devices. So definitely there will be a port. Fine. In some switches, in old switches, generally you got how many ports, guys? 24 ports. And in latest switches like 9200 or 9300 switches, you will get how many ports? 48 ports. Getting my point, everyone? I can show you. See, 24 ports Cisco switch. See, for example, I open anyone. I hope this is visible to all of you, right? So see, what is this? This is the Cisco switches. And what is this? These are called ports. Here, what do you connect? Here, PC you connect. What do you connect, guys? You guys will connect here PC. Getting my point, everyone? Yes or no? Right? And these are the 4 ports. By this port, we will connect our uplink. What is uplink? We will discuss in our coming classes. Okay. So I hope you guys understand what is the exact uses of switch. Fine. So now if we see image of Cisco 9300 switch. Are you guys able to see this one? Everyone. For example, this one. See, how many ports are there? Everyone. How many ports are there? 48 ports you guys will get here. How many ports? 48 ports you guys will get there. Fine. What is this? Now again you will ask, sir, there you show me these are the 4 ports. These are the 4 ports where you connect the uplink, right? But here on this switch, this is blank. But guys, this is not blank. Basically, Cisco, whenever Cisco is sending the device, either you will get the uplink or either you will not get the uplink. Fine. So here, what you need to do, you need to insert the network module. You need to purchase it additionally. Okay. So Ccna, this is the complete blank space. Here only one nut bolt is there. You just need to, you can just open this one by the help of a screw. Okay. And when you will open, it will looks like this. And here you can insert the network module. And there you will get what? There you can insert the uplink. Fine. It's clear. Okay. Now I hope you guys are able to unmute yourself. Fine. So if you guys are able to see this diagram, what is this? This is called, guys, power supply. What is? This is power supply. If you watch my one video, recently I uploaded one video how to take the console of the switch. There I on live I show you how we insert the power supply. Generally in a switch there will be a 2 power supply you will get. Why? Because of the redundancy. If one power supply will fail, you have another one. Getting my point? So that is something. This is the something you need to understand about the switch. Fine. Now, next thing is, I told you there is a one model that is called OSI model, right? And in OSI model is called the layered approach model. So in OSI model, there will be a different layers. Fine. What are those layers? We will discuss these things later. But right now, just understand, I told you router works at layer number 3 and switches works at layer number 2. Fine. And if you remember, I told you there are two types of address in a networking, right? Why we need networking? Sorry, why we need address in a networking? The answer is if you want to send anything over the network, definitely you need address. Without address, how can you send the thing? Getting my point? If I want to send a letter to anyone, if I don't know your address, how can I send? This is not possible. Similarly, in case of network, if you want to send your packet to the destination, you must need destination address like IP address and MAC address. Fine, everyone. So at layer number 3, which address works? Logical address work, that is called IP address. And at layer number 2, physical address work, that is called MAC address. Getting my point, everyone? So please understand these things. Now what you need to remember, switch. Switch works at layer number 2. And layer number 2 is called data link layer. Which layer, guys? Data link layer. Fine. First thing. Second thing you need to remember, I already told you, at layer number 2, which address works? MAC address works. It means now you can easily tell, sir, if we have a router, it means router operates at the IP address. Operate means router will take the forwarding decision on the basis of IP address only. Fine. And switch works at layer number 2. It means switch operates on MAC address. Getting my point, everyone? Now, in an interview, one interviewer asked one question, why router is called layer 3 device and why switches is called layer 2 device? How can you answer? You can answer very simply, sir, router is a layer 3 device because router takes every forwarding decision on the basis of logical address, that is called IP address, and according to me, IP address works at layer number 3. So that's the reason router is called layer 3 devices. Clear? Now, how you can tell switch is a layer 2 device? Then again you can say, sir, switches is called layer 2 device because switch operates at layer number 2. It means switch will take every forwarding decision on the basis of physical address, that is called MAC address. And as I know, MAC address works at layer number 2, that is called data link layer. Fine, an interviewer will satisfy. Getting my point, everyone? Is it clear to all of you? Done. So these are the two things you guys need to remember. Fine. Now there is a third point about the MAC address table. Guys, before switch, we were using one device that is called hub. I am talking about before switch. In the past, we are using hub, but nowadays we are not using hub. The problem is hub. What is the use of hub? Hub is also a networking device, and here you connect multiple PCs or end device like a switch. This is fine, but the problem is hub is not an intelligent device. Again, I am telling, hub is not an intelligent device. Now, what do you mean by intelligent device or non-intelligent device? Who can tell me? Tell me, guys. What do you mean by intelligent or non-intelligent? If I ask you, you guys are intelligent, yes or no? How can you answer? Nandan, what do you think? You are intelligent or non-intelligent?
We all are intelligent.
You are intelligent. Are you confident?
Yeah.
Okay. Yes, guys. As a human beings, we are intelligent because we have a capacity to store the thing in my mind and take the decision on the basis of my mind or memory. Right? Everyone, we can think, we have the thing, we store the thing in our mind, and on the basis of the decision, we are taking anything, right? In the same way, in networking, in switch, generally when packet will come, where for example, here you connect one PC and there is with this port, another PC is connected. For example, whenever this PC send anything to the switch open this packet and check the source address. What? Switch check the which address, guys? Source address. Fine. For example, switch will check, I am receiving this packet on which interface? This interface. For example, this interface is fast Ethernet 0x0. Then switch check whatever the packet I am receiving from this PC, what is the MAC address here? For example, PC MAC address is 0A. So this switch received two information. First, the MAC address in this packet, the source MAC address in this packet is 0A, and I am receiving this packet on the interface fast Ethernet 0/0. Two information. What switch will do? Switch immediately maintain these two information in the table that is called MAC address table, because switch has memory. Switch has, guys, memory. Fine. Switch has memory. It means switch will store the things in its memory. Fine. In the form of table that is called MAC address table. Fine. So switch will make an entry like this. I am receiving one MAC address 0A on which interface? Fast Ethernet 0/0. Getting my point? Understand? For example, if PC number 2 is connected, when PC number 2 will send anything, for example, this is fast Ethernet 0/1 and MAC address is 0B. So when switch will receive the thing, what switch will do? Switch will make an entry 0B. This is the MAC address of PC number 2, and I am receiving this MAC address on fast Ethernet 0/1. So that's the reason I am telling you switch is an intelligent device, because switch has memory and switch is storing the thing in its memory. So next time whenever any packet will reach on the switch, first of all, switch will check its MAC address table, and according to the MAC address table, switch will take the forwarding decision. So that's the reason I am telling you switch is an intelligent device, because switch has memory. But in case of hub was called non-intelligent device. It means hub do not have any memory. So it means hub was not storing anything in its memory, because it is non-intelligent device. Then again you guys will ask, sir, if hub is a non-intelligent device, then actually how hub was operating? Yes, you are correct. For example, this is the PC number 1, this is the PC number 2, this is the PC number 3, and this is the PC number 4. 4 PCs are there. For example, PC number 1, on PC number 1, IT person is sitting here. And on PC number 4, also IT person is sitting here. Here, for example, HR person is sitting here. And here, for example, manager is sitting here. And for example, this IT person and this IT person is close friend. Close friend. Fine. So this person try to send a message to this person, and this person is sending, I love you. Packet will reach on hub. What hub will do? Hub is not a non-intelligent device. It means hub do not maintain any table or any entry like switch, because switch maintain a MAC address table. Switch have no such table. So what hub will do? Hub will broadcast this packet towards here, here, and here. So what do you think? What will happen? This person received the packet, that is fine. But this I love you is receiving HR and manager both. So is this safe? Answer is no, this is not safe. Getting my point, everyone? This person's intention is want to tell I love you to this person. But who is receiving? HR madam is receiving, right? Everyone. And manager is also receiving. I don't know what these two person will do. Getting my point? So that is the problem. So problem is, see here. Here, by the help of hub, we are not receiving the confidentiality and integrity, because as an end user, we want, if you remember in the last class, I told you about the CIA, if you remember, right? So here we are not receiving these things. Getting my point, everyone? So that is the problem with the hub. So whenever any packet will receive on hub always broadcast it. It means here, for example, if he wants to communicate with it, it means data will flow like this. Then there is no need to send this packet here on this link. It means unnecessary you are utilizing these links. Unnecessary you are utilizing these links. So that is the problem. Getting my point? Understand? So to upgrade this, we have now different device, or you can say upgraded device, that is called switch. On switch, we have a memory, or you can say switch is an intelligent device. So switch can maintain a table, and according to that table, switch will take the forwarding decision. It's clear to all of you. I hope you guys understand something. Done? Now the next one is, a switch is used to connect multiple end user in the LAN network. I already told you. The switch has many ports compared to the router. In yesterday class, I told you these things. And even I show you in the GNS3 also, right? So if you are using the router, definitely router has very less ports compared to the switch. In router, generally you are getting 5, 6, 8 ports like this. But on a router, you will get 24 ports, 48 ports like this. Fine. For example, if this is the floor and on this floor, for example, the number of user is 200. 200 users are there. So as a network admin, how many switches you need? Nandan, how many switches you need? For example, you got a task, your manager is telling, hey Nandan, do one thing. There are 200 users on this floor and you need to configure the switch here on this floor. So as a network admin, how many switches you need?
One
How
switch.
many switches you need?
One switch.
One switch? How you are telling one switch? On one switch, maximum how many ports are there? For example, you are using 9300 model switch. So here maximum ports you will get how much? 48 ports, right?
Yeah.
48 ports.
48 ports.
So if you have a 48 port, it means maximum you can connect 48 computer with this switch. But your requirement is how much? 200. Getting my point, everyone? So you need more switch? Yes or no? So if you divide 200 by 48, my mathematics is weak. Who can tell me the answer? Approx? I think 6 or 7 like this. Right? So it means you need these number of switches on this floor. Is it clear? Everyone? Okay, cool. The switch is used in our LAN network. It does not provide the connectivity between the LAN networks. Yes. For example, this is my LAN number 1 and this is my LAN number 2. In LAN, we are using the private IP address. For example, here I am using 10.0.0.0 and here I am using 20.0.0.0. It means in this LAN, we are using the different network and in this LAN, we are using the different network. Now tell me, can we make communication possible here with the help of switch? I am talking about the layer 2. Don't think I am talking about the layer 3. Okay, so just tell me, can we make communication possible here with the help of switch? Answer is no. Why? Because here you need the communication between the LAN. Here you need the communication between the LAN, or you can say between two different network, two different subnet. So if you want to make communication possible between two different subnet or two different LAN, you need layer 3 device that is called router. Getting my point, everyone? Is it clear to all of you? Everyone. And for example, if this is the floor and on this floor, let's suppose 200 users are there and all the 200 users belongs to the same project and you configure 6 switches or 7 switches. So yes, you can make communication possible from this PC to this PC. There will be no problem because all are in the same network. All are in the same network. So what is the conclusion? If you want to make communication possible between the same LAN, you can do it by the help of one switch. You can make communication possible with the help of switch. But if you want to make communication possible between the LAN, what you need? You need a router or layer 3 device. It's clear, everyone. Now, switch can unicast, multicast, and broadcast. In yesterday class, I told you about the router. Router can unicast, mostly in case router unicast. In some case, router will multicast and broadcast. Right, everyone? When you configure the routing protocol, then it will multicast and router will generate the ARP, and that is the scenario of broadcast. But in case of switch can forward your packet unicast, multicast, or broadcast. Clear, everyone? I hope you guys understand. Done. Now, in the first class, if you remember, I told you something about the simplex, half duplex, and full duplex. Right, everyone? I hope you guys are aware about it. If not, please watch the first class. There we already discussed about the mode of communication. There are 3 modes of communication: simplex, half duplex, and full duplex. So switch operates at which duplex, guys? Full duplex. Full duplex means By the help of switch, you can send and receive the data at the same time. At the same time. That is called full duplex. Is it clear to all of you? Understand? Now, here I mentioned two things. When choosing a switch, you need to decide between the managed or unmanaged switch. The main difference is how to control you over the switch setting. Guys, generally, there are two type of switch. One is called unmanaged switch and second is called managed switch. When you read the word, I hope you guys can easily understand. Managed means you can manage it. Unmanaged means you cannot manage these things. Try to understand what is the difference between managed or unmanaged. Unmanaged means just like a box. This is nothing. This is just like a box. Here everything is pre-configured. Everything is pre-configured. Pre-configured means not everything. That is the basic switch. Generally for small offices you guys will get, but generally nowadays you will rarely you will see these things. But yes, unmanaged means just like a simple box. Here what you need to do, you need to connect your PC just like fine. You cannot configure this unmanaged switch. For example, you want to create the VLAN, you want to implement the ACL, you want to configure anything, you can't do anything. This is just like a box. It means that is already pre-configured. You just power on it and connect your device, nothing else. So that is called unmanaged device. And that's the reason I am telling you, rarely nowadays you guys will see the unmanaged switch. Because in every corporate or every company, there will be a managed switch. Managed switch means you can manage this switch accordingly. You can manage this switch accordingly. Getting my point? For example, I want to improve the performance. I want to change the VLAN. I want to implement the security policy. Everything you can do in managed switch. But in unmanaged switch, you can't do anything. Getting my point? So see, I already inserted the image. This is called unmanaged and this is called managed. Clear? Everyone. I hope you guys understand. Now, here is the difference. What is the difference between managed or unmanaged? See, managed means provide full control over the traffic. Yes, if you are using the managed switch as a network admin, you have full control over your traffic. For example, you can create the VLAN. For example, if you want to restrict any traffic, you can do it like this. But in unmanaged switch, you have a limited control. You have limited control because everything is already pre-configured there. And managed switch has advanced feature like VLAN, ACL, port security. Yes, you can configure these things on the managed switch, but on unmanaged switch, you can't. Managed switch price is also quite high compared to the unmanaged switch. Fine. And what about the update? Yes, in managed switch, you will get the regular update from the Cisco side. But in unmanaged switch, you have a minimal, you can say maintenance, or you can say very less maintenance. You do not need to upgrade the switch again and again. No. But in managed switch, generally we need to upgrade the switch. And managed switch we are using in the large network. And I told you, if you have a small network, small offices, there you can use the unmanaged switch. There is no problem. So that is the difference between managed or unmanaged switch. Now, on the basis of behavior, now we are discussing, guys, managed switch. Okay, now remove the things about the unmanaged switch, because in our CCNA we are not going to discuss about the unmanaged switch because this is not useful for us. Okay, so we are discussing about the managed switch. So in managed switch, according to the behavior, generally we divide the managed switch in two categories. First one is the layer 2 and layer 3. How can you answer if anyone asks you, what do you mean by and how you are categorized layer 2 and layer 3? Guys, what is layer here? If I am writing here layer, it means I am talking about the OSI model, because in OSI model we are getting the layers. Yes or no? Yes. And if I am writing here layer 3, it means definitely I am thinking about OSI model, because in OSI model we have a layer 1, layer 2, layer 3 like this. Yes, exactly. Layer 2 switch means definitely it works at layer number 2, that is called data link layer according to the OSI model. And if this is the layer 3, definitely it works at layer number 3, that is called a network layer in OSI model. Getting my point, everyone? Now, first thing, this one you need to remember. Second thing, if this is the layer number 2 switch, it means on layer number 2, which address works? Physical address, that is the MAC address work. And on layer number 3, which address works? IP address works, I already told you. Now, on the basis of this, I can tell layer number 2 switch or L2 switch will take the forwarding decision on the basis of MAC address only. And layer number 3 switch can take the forwarding decision on the basis of layer 3 also. So that is the main difference between L2 switch and L3 switch. For example, 2960 switch, that is the proper L2 switch. If we are talking about the 9300 model switch, that is the L3 switch. It means here on this switch, what you can do? You can configure the routing also. Getting my point? So that is the main difference between L2 switch and L3 switch. Here I mentioned some differences. Please see. Operates at data link layer. I already told you. Layer number 2 switch operates at data link layer. It means it will take every forwarding decision on the basis of MAC address only. But L3 switch will take the forwarding decision on the basis of IP address also. On L2 switch, or L2 switch has no routing capability. It means you cannot configure the routing here. But on L3 switch, yes, you can configure the routing. You can configure the IP address. Where generally we are using the L2 switch? Yes, generally we are using the L2 switch where we have a small network setup. And generally you can say, for example, if on the same floor, if the same subnet is there, it means, for example, 200 users are there and all the 200 users are in the same VLAN, same subnet, then yes, you can use. But in real time, rarely you guys will see these things. I can tell you on the basis of my experience. See, generally, when I am working as the network engineer, what I am thinking and what I am getting, for example, this is the floor and the capacity of this floor is 200 users or 500 users. This is not possible generally. For example, I have in my company, for example, we have a client Dell. We have a client Facebook. For example, I have a client LinkedIn. For example, these are the client in my company. So just tell me one thing. For all the client, can we use the same network? Answer is no, never. We cannot use the same network for all the 3 clients because all the 3 clients have different requirement. If you assign the same subnet, same network to all the clients, there will be a mess. Because, for example, Dell's requirement is Dell want Cisco.com is allowed. Dell want Facebook.com is allowed. Facebook wants, for example, Webex.com is not allowed. How you implement the policy? There will be a very difficult. This is not possible to implement the policy like this. Generally, we implement the policy on our firewall, like on Palo Alto. So whenever we are implementing the policy on the firewall, we are implementing on the subnet. And for example, if there is only one subnet, for example, we have a 10.10.10.0/24. This is the subnet. So if you implement the same policy on this subnet, it means that policy will be implemented or applicable for all the 3 clients. But you see, all the 3 clients have different requirements. Then what will happen? It will create the mess. So in real time scenario, different client have different network, different subnet in the same company. Getting my point? So for example, if there are the capacity of this floor is 200. For example, Dell has 50 users. This one, Facebook has 50 users and LinkedIn have 100 users. So total is 200 and I have only one floor and I want all the 3 clients user will sit here. So what I will do, I will assign like this, like this, like this. I will assign this area for Dell. I will assign this area to Facebook. I will assign this area to LinkedIn. But there will be a different network. Yes or no? Everyone. For example, here I assign 10.23.180.0/24. For example, here I assign 10.23.160.0/24. Here I assign 10.23. 150.0/24. I'm just giving you example. So see, for Dell, I assign the different network. Here I assign the different network, and here I assign the different network. On Dell, I assign 10.23.180.0. Here I assign 10.23.160.0. And here I assign 10.23.150.0. So all the clients have different subnet. And all the clients are in the same floor or different floor? On the same floor. Now tell me one thing. On the same floor, we have a hub room where we implement or where we store our switches. And for example, you guys already told me, sir, for 200 user, how many switches you need? 6 or 7 switches you need, right? For example, 6 switches are there. Now tell me one thing. Can we use here L2 switch and it will fulfill my requirement? Yes or no? Tell me guys, I am asking to all of you. If I implement here 2960 series switch as a L2 switch, can we achieve our task? Can it fulfill my requirement? I am asking.
No, no.
Tell me, Nabil?
No, sir. No, sir.
No? Manjunath? Ram Babu? Nandan? My question is, does it fulfill our requirement? Answer is simply no. Because we have a 3 different subnet. It means different network. And what I told you about L2 switch, if you are using the L2 switch, it means you can make communication possible in the same network. But you have a different network. In this scenario, you have different subnet. So definitely what you need? You need L3 switch. Getting my point? If you implement the L2 switch, what will be the problem? For example, if Dell wants to communicate with Facebook, it is not possible. Right now, everyone, yes or no? Getting my point? So what we need? L3 switch. What we need? L3 switch. Done? Everyone. Understand?
Yes, sir.
Yes, L2 switch is cheaper and L3 switch is definitely very expensive. Fine. And generally faster. Yes, L2 switch is faster. L3 switch is little bit slow. Why? Because L3 switch provide you the routing. And if you are using routing, then definitely what will happen? It will little bit slow. Fine. Okay. That is something about the switch. Clear? Now, in previous class, if you remember, I told you how to take the console of the switch. Yes or no? Tell me. I'm just opening the switch. Is it visible to all of you, my screen?
Yep.
Tell me, right? Okay, cool. So basically, guys, this is switch. Okay. So in switch, right now we are on which mode? Who can tell me? In previous class, we discussed these things. We are on privilege mode, right? Everyone, we are on privilege mode. In yesterday class, I show you on the router, right? And on switches also we have the same mode. That is called privilege mode. How can we go in the global configuration mode? What is the command, guys? Conf space T. We are on which mode? Global configuration mode. What is the difference between privilege mode and global configuration mode? In privilege mode, generally we are writing the command for view the configuration. Yes or no? For example, we are here in the privilege mode. I am writing so IP interface brief. See, if I want to check the interface, on this interface, do we configured any IP address or like this? No, we are not able to see. For example, I am writing so interface Ethernet 0/0. If I want to check the detailed information about this interface, yes, we can check. So interface Ethernet 0/0 is up, connected. Getting my point, everyone? So generally in privilege mode, what we are doing? We are just writing the command to show the configuration. Fine. Now, for example, we move in global configuration mode. In global configuration mode, if you remember, I told you whatever the thing you will configure, it will be implemented for globally. Yes or no? For example, I am writing the host name Shubham. So here host name change. Getting my point, everyone? Understand? So if I want to check the running configuration, what is the command? So running configuration. So if I write the so running configuration command, it means by the help of this command, you guys will able to see all the configuration done here on the switch. See, when I write here, so running configuration, see host name. I change the host name of this device, right? So that's the reason I am able to see here. Getting my point, everyone? Yes or no? Clear?
Yes.
Yes. And if you remember, on Monday, don't worry, we will discuss the command for router and switches both, no problem. Now, for example, on switches, all the ports of the switch is called switch port, right? Everyone, yes or no? Right now, every port of the switch is called switch port. Now, tell me one thing, by default, all the port of the switch is access port or something else? For example, I am writing so interface Ethernet 0x0 switch port. See, I write here this interface. I want to check the status of this interface, and after that I write switch port. See, switch port is enabled. Switch port is enabled means I told you na every switch is called every port of the switch is called switch port. Right now, what is the administrative mode? Dynamic desirable. That is something different. See here, what is access? Tell me yes or no. Yes, na. So please remember every port of the switch is by default access port. Which port, guys? Access port. Clear, everyone? Now the next thing is the basic thing about the firewall. What is firewall? Do you guys know something about the firewall? How actually the firewall works? Anyone? Anyone? No? See. For example, I'm just giving you one scenario. Then I hope you guys will understand something about the firewall. Basic thing. For example, this is the floor. And on this floor, for example, there is a access switch. And that is which layer, guys? That is called access layer. Right now, in a company is generally divided into two categories. Fine. Access layer, distribution layer, and then there will be a WAN. Understand? So that is the access layer. Then there will be a distribution layer. On distribution layer, you will get the DR1, DR2. That is the router. Or you can say either you can use the router or either you can use the L3 switches. In maximum company, use the L3 switch. Fine. Between DR, we have a two uplink. And from this access switch, one uplink is there, one uplink is there. This is nothing, this is trunk.
Trunk.
And through this DR, what will happen? We have a firewall 1, firewall 2. Fine. And between these two firewall, we have a two link, or you can say here we configure the ether channel. Okay. And this again DR connect like this. Like this. Fine. Done, everyone. Now, how actually the thing work in the real-time scenario? Try to understand, try to focus. For example, here, if you are using any access switch, for example, if there is a VLAN 180, what is the VLAN? VLAN 180. Fine. So what you will do, you will configure the thing on this DR as well as you will configure the thing on Palo Alto. Yes or no? For example, try to understand the scenario. Here, for example, there is a PC and this PC has VLAN 180. What this PC will do? This, for example, you are searching anything. For example, you search facebook.com. Facebook.com. What will happen? This PC send the packet to this switch. Yes or no? Tell me yes or no. Right now, on this PC, you search the facebook.com. Packet will go on this switch. What this switch will do? This switch has your packet. Yes or no? Right? On this packet, what this switch will do? This switch will tag the VLAN. For example, you are using VLAN 180. So this switch will tag this packet with VLAN number 180 and forward this packet through this trunk towards the DR. For example, this is the L3 switch. What this DR will do? this DR first of all maintain which table, guys? ARP table. And on ARP table, this DR maintain the entry that I received this packet on this interface with MAC, for example, 0A, and I have received this packet on 0 by 0. Now this DR will check its ARP table or MAC table to find out, do I have entry with this MAC address already? Then this router will get to know I do not have any entry. So what this DR will do? Basically, switch has one rule, or you can say one feature, that is called unknown unicast forwarding. It means, I told you, whenever any packet will reach on the switch check which table, guys? MAC address table. And on the basis of MAC address table, switch will forward the packet. Exact? Yes or no? Everyone. Right? Tell me, guys. You guys are so silent. Right? Yes. Switch maintain one table that is called MAC address table, and on the basis of that MAC address table, switch will take the forwarding decision. But tell me one thing, if you have a scenario when switch do not have entry in its MAC address table, then what switch will do? Switch will broadcast the packet. What, guys? Switch will broadcast the packet, and that is called unknown unicast flooding. That is called what? Unknown unicast flooding. Do you guys understand? Yes or no? Are you tell me yes or no at least?
Yes. Yes, sir.
Okay. Cool. Yes, please. If not, I will repeat once again.
Sir, please
No?
repeat again, sir.
Okay, cool. See, guys, this is switch. This is PC number 1. This is PC number 2. This is PC number 3. And this is PC number 4. The MAC address of this PC is 0A, 0B, 0C, 0D. I'm assuming this switch already know all the MAC address 0 by 0, 0 by 1, 0 by 2, and 0 by 3. So switch has MAC address table, like on 0 by 0, I have MAC address 0D. On 0 by 1, I have MAC address 0C. On 0 by 2, I MAC address 0B connected, and on 0 by 3, which one is connected? 0A is connected. Fine, everyone. Yes or no? Clear? Now, on PC number 1, for example, on PC number 1, IP address is 10.1, 10.2, 10.3, 10.4. On PC number 1, I write the command ping 10.4. What PC number 1 will do? PC number 1 generate the packet. In this packet, source IP will be 10.1. Destination IP address will be 10.4. Yes or no? Are you tell me? Source MAC will be 0A and destination MAC will be 0D. I'm assuming PC number 1 already know what is the MAC address of PC number 2. Fine. So PC number 1 send the packet. This packet will reach on the switch. This packet reach on the switch on this interface. What switch will do? First of all, switch will check what is the source MAC address. What is the source MAC address, guys? 0A, right? Now, what switch will do? Switch will check its MAC address table. Then switch will find, yes, for 0A, I already have entry here. So what switch will do? Switch will just update it once again. Or not understand like this update, or you can understand like just reset its time. There is a rule. Rule is, in MAC address table, entry will be by default for 300 seconds. How many seconds, guys? 300 seconds. It means all the entry switch is stored for how much time? 300 seconds. And for example, switch already maintain this entry for 200 seconds. After 200 seconds, switch receive immediately one more packet here on this interface, this packet. Then switch check what is the source MAC address, 0A. And this is already present in my MAC address table. Then what switch will do? Switch update its time only. Because 200 seconds already finished, right? It means if switch will not receive any MAC address on this interface till 300 seconds, then what switch will do? Switch will remove this entry from its MAC address table. That is the rule. And that is called which time? Aging time. That is called which time, guys? Aging time. So aging time means when switch will not receive any MAC address for any interface till 300 seconds, then switch will remove this entry from its MAC address table. And see, I told you how much time already lapsed? 200 seconds already lapsed. It means how much time left? 100 second left. It means if switch will not receive any MAC address here for 100 second, switch will erase this entry from the MAC address table. Yes or no? Yes? Now, PC number 1 send the packet reach here. Now switch check, the MAC address is 0A, source MAC address is 0A, and I receive on interface 03. Switch immediately check its MAC address table and found, yes, on 03, I already have MAC address 0A. Now what switch will do? Switch just update the time immediately. Now what is the aging time? Now for this entry, aging time is 300 second. But previously what happened? 200 second was left, na? Yes or no? Only 100 second was left. But now immediately switch received the packet. Now switch again update its aging time, and now the fresh time is again 300 second. This is the first thing. Now switch will check what is the destination MAC address. Destination MAC address is 0D. Now switch will check is 0D is present in my MAC address table, yes or no. Then switch will find yes, 0D is present in my MAC address table on interface 0 by 0. So switch will forward this packet through 0 by 0, and finally your packet will reach on PC number 2. Getting my point? Anyone who do not understand? It's clear. Finally, PC number 2 receive this packet. What PC number 2 will do? PC number 2 will generate the reply. In this reply, what will be the source IP address? 10.4. What will be the destination IP address? 10.1. Because PC number 2 sent for PC number 1, na? Yes or no? Yes.
Yep.
So destination will be 10.1. What will be the source? Source MAC will be 0D. And what will be the destination MAC? 0A. And packet will reach on switch. What switch will do? Again, same process. Switch check what is the source MAC. Source MAC is 0D. Is 0D is present in my MAC address table? Switch will find yes, 0D is present in my MAC address table on interface 0 by 0. What switch will do? Switch upgrade its aging time. So now for this entry, aging time is again 300 second. Fine. Now switch will check what is the destination MAC. Destination MAC is 0A. And 0A is present on which interface? 0 by 3. And switch will forward this packet through 0 by 3. And finally, packet will reach on PC number 1. Anyone have any confusion here how packet is flow? Anyone? Guys, I told you in the very basic way. Right? Now, on the basis of this, can anyone tell me this type of I already told you, if you remember in yesterday class, there are three types of communication: unicast, multicast, and broadcast. Now tell me, this type of communication is unicast, multicast, or broadcast?
Unicast.
Unicast, exactly. Because PC number 1 is sending and PC number 2 is replying. Your packet is not going towards PC number 3 and PC number 4. So that is called unicast communication. So that is the first scenario. But think about, for example, this is the switch. Again the same thing. PC number 1, PC number 2, PC number 3, and PC number 4. Fine. Same. 10.1, 10.2, 10.3, 10.4. Fine. Now here MAC address is 0A, 0B, 0C, 0D. Any problem? Everyone? No? Okay. Switch has already maintained the MAC address table, right? It means on 0 by 0, what is the MAC address? 0A. On 0 by 2, MAC address is 0C. On 0 by 1, MAC address is 0B. And on 0 by 3, MAC address is 0D. Anyone, any problem? Tell me. No? Tell me guys. No, na?
No.
No. Cool. PC number 2 and PC number 4, sorry, PC number 1 already communicated here just some second ago. Fine. Now, see the scenario. Now, PC number 2 and PC number 1 is not sending any packets with each other till 300 second. How many second, guys? Till 300 second, PC 1 and PC 2 is not exchanging any packet. What will happen? Switch will erase the entry from its MAC address table because by default the aging time is how much? 300 second. So if switch will not receive any MAC address till 300 seconds, then switch will immediately remove the entry from its MAC address table. Yes or no? Tell me guys, yes, na? So what switch will do? Switch will remove 0D entry from here, MAC address table, and 0A entry from its MAC address table. Yes or no? Everyone, tell me. Right? Tell me guys, yes or no? Yes. So it means on MAC address table only there is a 2 entry. Fine. Now come to on the PC. Guys, PC also maintain ARP table. Which table, guys? ARP table. You guys know, na? Everyone understand, na? PC also maintain which table? ARP table. For example, this is my PC.
Hello.
How can you check ARP space slash A? See, this is the ARP table of my PC. My point, everyone. This is the ARP table of my PC. Similarly, every PC, guys, Rambabu, please note. PC also maintain the ARP table. And one more thing, in ARP table, whatever the entry is there, that entry for, I think, around for 8 hours. How much, guys? 8 hours. Fine. And in ARP table, PC maintain 2 information. What is the IP and what is the MAC address for that IP? Fine. So on PC number 2, what is the IP address of PC number 2? 10.1. So for 10.1, IP address is 0A. And I already told you, just before some second or just before 300 seconds, PC number 2 and PC number 1 was already communicated. Yes or no? Yes? Tell me yes or no? Yes, na? 100 seconds, both already communicated, na? So it means PC number 2 already aware about the MAC address of PC number 1. Yes or no? Yes. So PC number 2 already maintain IP address 10.4. PC number 2 already know this IP address because just 300 seconds ago, both devices already communicated. So, and this entry will be for 8 hours. So for 10.4, IP address is 0. What is the MAC address, guys? I think 0D, right? So this is the MAC address here. Anyone have any question, any problem? This is fine. Tell me, right?
Yes, sir.
Okay,
Yes, sir.
Cool. Now, what you write a command ping 10.4. What you write here? Ping 10.4. You are pinging from PC2 to PC1. What PC number 2 will do? PC number 2 will generate the, again, ICMP packet, right? Yes or no? Everyone,
Yes, sir.
ping packet, right? So in this packet, what will be the source IP address? 10.1. What will be the destination IP address? 10.4. What will be the source MAC address? 0A.
A.
And what will be the destination MAC address? 0D. Now, don't think, sir, why PC number 2 know the MAC address of PC number 1? Guys, whenever you are writing the destination IP address 10.4, PC number 2 look its ARP table and try to find out, does I have MAC address for this IP? If PC number 2 will get the MAC address for this IP, then PC number 2 will generate the ICMP packet. And if PC number 2 will not get the MAC address for that IP, PC number 2 will generate the which packet? ARP packet.
And hold the ICMP.
If anyone don't know what is the difference, don't worry. In our coming classes, I will tell you in a detailed way. Guys, basically, ICMP is the packet. Whenever you are writing the ping command, ping is the utility that use the ICMP protocol. So it will create the ICMP packet. ICMP packet only and only create when your device know the source IP address, destination IP address, source MAC address, and destination MAC address. Fine. But if in some case your device don't know what is the destination MAC address, so in this case your device will generate the ARP packet to find out the destination device MAC address. I hope it's clear to all of you what is the use of ICMP and what is the use of ARP. Clear?
Yes, sir.
Fine. Now, PC number 2 has all the information. Now, on the basis of all the information, who can tell me this packet is unicast packet or broadcast packet? Who can tell me?
The unicast packet.
That is the unicast packet. Why? Because for every information you have, you have every information, right or wrong? Right? Nah, there is nothing is. You don't have everything you have. It means that is called unicast packet. So this packet will reach where? On switch this interface. What switch will do? Switch will check which address, guys? Source address. What is the source MAC address here? 0A. So what switch will do? Switch will learn on 0 by 0, I am receiving 0A. So switch immediately learn these two information in which table? MAC address table. On 0 by 0, I learn or I receive 0A MAC address. This is fine, everyone. Clear? And one more thing. Please understand or please remember, always remember this one. Whenever any device receive any packet, device perform two things. First, learning and then forwarding. Fine. So this is the learning task. So switch learn the thing and make a entry in which table? MAC address table. Now come to the forwarding task. Now switch will check what is the destination MAC address. What is the destination MAC address, guys? 0D. 0D. Switch will check, is 0D present in my MAC address table? Answer is no. 0D is not present in my MAC address table. Before some time, it was there, but due to aging time, it was removed from my MAC address table. It means now switch don't know 0D, right, everyone? So what switch will do? Switch will broadcast this packet through every ports. Through every port. This device receive this packet. This device check what is the destination MAC address. This device find destination MAC address is 0D, but my MAC address is 0B. It means this packet do not belongs to me. It means that device immediately drop this packet. Similarly, this device also drop this packet because this device MAC address is 0C and in this packet destination MAC address is 0D. This device also drop this packet. Who will accept it? PC number 1 will accept it. And PC number 1 will generate the reply. And in this reply, what will be the source IP address? Again, 10.4. Destination IP address will be 10.1. Source MAC address will be 0D. And destination MAC address will be 0A. Yes or no? Everyone, tell me.
Yes.
Right? Packet will reach on switch. Packet reach on switch. What switch will do? Switch check what is the destination. First of all, switch maintain the entry in the MAC address table. Switch check what is the source MAC address? 0D. And 0D I am receiving on which interface? 0 by 3, right? So on 0 by 3, MAC address is 0D. And update in its MAC address table. Fine. Now switch will take the forwarding decision. Ram Babu, please mute yourself. Now, switch will check what is the destination MAC address. Destination MAC address is 0A. Switch will check 0 is. Ram Babu, please mute. Okay, cool. Now, this switch will check what is the destination MAC address. Destination MAC address is 0A. Switch will check 0A is present in my MAC address table. Yes, on 0 by 0. Switch immediately forward this packet to PC number 2. So I hope now you guys understand two different scenario. In first scenario, when switch received the unicast packet and all the entry was there on switch MAC address table, then in this case, how switch forward the packet? There will be a communication like unicast communication or one-to-one communication. Yes or no? In first scenario, right? Everyone, can you tell me?
Yes, sir.
Right now? Okay. And in this scenario, what is happening? PC number 2 send this packet, and this packet was unicast or broadcast? Unicast packet. But what switch did? Switch broadcasted. But what switch did? Broadcast. And that's the reason this is called unicast. Unknown unicast flooding, or you can say unknown unicast broadcasting. So this is the rule when switch has entry in its MAC address table, then switch will perform one-to-one communication, or you can say unicast. But for example, if any scenario, I already told you the scenario. For example, when MAC address will erase from the MAC address table due to the aging time, then in this type of scenario, switch obviously receive the MAC address unicast packet, but switch will perform the broadcast. And that is the interview question. Why? I can tell you the scenario. Interviewer will ask you, tell me if this is the switch and if this switch will receive a unicast packet. First of all, interviewer will ask you, just tell me, switch can unicast or broadcast? You can tell, yes, switch has behavior, switch can unicast as well as broadcast. Fine. Now interviewer will ask you the cross question. Tell me, if switch will receive the unicast packet, what switch will do? You can easily tell, sir, switch will unicast it. But no, you need to ask him, tell me, is all the entry, all the MAC address table entry already there on the on switch MAC address table? If yes, then switch will do the one-to-one communication or unicast. If not, then no matter, switch will receive the unicast packet or broadcast. Switch will always broadcast. I hope this is clear to all of you. Anyone who do not understand, please let me know. Is it clear to all of you? Everyone?